All right, let's go on to lists. So list containers, doubly linked list. What? We're recording again. Yes, congratulations.
Yeah, you said we weren't done.
So you can create a list pretty much the same way. Look, it has push back, pop the front, pop the back, and you can insert in the middle.
Yeah,
Push. All right, in push. So let me go and let's see. Oh, that was the wrong key command. My. We'll make a new one. Tab new. We'll go listfun.cpp. Hey, it's the same thing. So now we're going to use list. And now let's go $$S vector with list everywhere. All right, let's see if that actually works. I just replaced the word vector with list. Wow. Oh, that was close.
So you have to replace back. No, wait.
I can still. I gotta
You
replace.
can still call it back.
I need to replace it though. $$S vec with. I'll just call it LL. I'll call it LL. That sounds great. Pattern not found. All right, still the same. So no matching for operator. So you can't do a subscript operator on a linked list. Wow. Wow. Let's see what if you can do something with it. C++ STL list. That's why I need the internet, because I don't remember all the commands.
Yeah, you gotta use the internet.
Wow. And as you can see, also for some reason the C++ website's always slow.
It is.
I don't know why. So we have iterator. Let's see, we have begin, end, empty, max size, front, back, assign, push, blah, 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 blah. So we don't have anything. So in a list, you actually can't do random access. How about that? There's no random access for the STL. It really is. Or really isn't. So we'll get rid of those two commands. And then we'll rerun it. Ooh, it compiled. Let's see if it actually runs. See? Now we just replaced it with the list, and it did the same thing. Well, that was fun. So there you go. All your old commands will still work with your list, except for the subscript one. Now there's a couple. Let's go and talk about a new algorithm. Oh wait, look, you can push to the front, and you can pop from the front. Do I need to do any examples of this?
Yeah.
Thank you.
Thank you.
Ah. You can copy from one list to another. All right, fine. So we have a list. I'll make it list 2. And if we go down to the bottom, I'm going to copy over list 2, over linked list 2 with the items of linked list. So that's standard copy into ll2.begin from ll.begin to ll.end. And then let's go copy pasta some for loop. This is a good for loop. Except of course we'll have it go on ll2. Alright, let's see how that pans out. Terribly. Copy, expect. Okay. Whoa, it's failing. Wow, it failed terribly. Let's see what happened. L1 begin. Wait, copy contents. Oh. So the last one is where you want to copy to. Really? Alright, fine.
I love how surprised you are by it.
Yeah, well, it's C++. There we go. Ooh, SecVault! My favorite.
I had a sec fault the other day.
I know. Aren't they grand?
Totally.
You'll find out that trying to debug the trying to debug the STL is just terrible. L1 begin, L1 and L2. Copy contents of L1 to L. Oh, looks like this is failing miserably. Well, can we just copy some of them? What?
I didn't like that.
It really hated this. Alright, let's see if we can get what this error actually is. Oh, C++. Alright, here we go. No match for operator. Why is that not allowed? That's weird. Okay, well, we'll just do plus plus. Alright, took that. I wonder what the problem is. Why can't we go to the end? What if we go end minus minus? Bet you I know what the issue is. Nope. Apparently not. What is going on here? List 2, array 7. Are we adding things to the first array? Aren't we? We're doing like push. Yeah, we're doing pushback. Is that what's confusing everything? Yeah, that's what's confusing everything. So the lists of the size of each list has to match when you do a copy. That's the problem. Wow. All right. But what that does imply is that we could do this. We could start at the next element and then copy everything over. No? Really? Really gonna give me this much grief?
Yep.
What? Okay. Alright, for some reason, they have to be the same size. Let's go see if the internet will tell me why. STL copy algorithm. Isn't this amazing? Copies into the range, the result, the blah, blah, blah. You can copy things backwards from first to last. An iterator, complexity, data races, exceptions, throws. Oh, it doesn't tell you. Huh. Alright. Look, you can also fill and you can replace. Alright, so you can use copy. With insert iterators, you can modify the behavior of copy algorithm. Oh, so you can back insert new elements at the end, insert at the beginning, insert at a specified location. So, if you want to back insert them to L2, notice it's taking the elements from first one and appending to the end. Do front inserter, notice it's taking the front inserter to L2. It's wow, it's putting them in backwards, but in the beginning. Okay. One second.
Oh, that makes sense. Yeah.
Front, yeah, because it's front inserting to L2 from the beginning of to the end. Search new elements at the beginning. Right, so it's actually because it inserts the 1, then the 3, then the 5, then the 7, then the 9 to the front. So of course it's going to come out that way. And then add contents at the old to the beginning of there. Is he still copy? All right. So really, we wanted to use the inserter to do this, but that's or the back inserter when we were adding, but that's okay. All right. So we go over here, std inserter. So with an E or with an O? With an E. Now if we run it. Oh, I meant to put front inserter. There we go. Or back inserter. There we go. There we go. So now I put it at the end, all the new elements. Okay, kind of hard to see here, but actually if we just create a list, let's make it empty. Insert it at the back. Oh, it did not like that.
Of course not.
Why did it not like that?
It's picky.
Okay.
Why?
It had a problem with the constructor. Apparently you can't create an empty linked list.
Okay.
That was its issue.
That's dumb.
I agree. Sort and merge. All right. So you can sort and then merge things. Okay, this is going to be great. Since it's a list, you can just call .sort. In fact, I think vector has the same thing. ll.sort, ll2.sort, and let's go and print one of them out right after this amazing sort. Let's
You
go.
should make a print function.
I should make a print function. So we're going to show some sorting. And we should, you're right, this should maybe be a print function. Okay, fine. Void print list of int. Ooh, that was bad. List. End of list. There, I made a print function. Are you happier now? Print. What did I forget? Does anyone know? I know what I forgot. It's not declared in the scope because it's called a list, not LL. All right. Hey, look, it's sorted now. Ta-da! All right. And then merge would actually merge two lists together. Note that L1 would contain everything, and then L2 would be emptied. So some things can take a, some algorithms can take an argument. For example, if you wanted to create your own function on how to order things, for example, you have your own object, you could write your own function about how you compare those two objects to give it a certain ordering, and then you can pass that to sort, and it will actually sort them for you. All right. Welcome back.
I'm back. 2 hours later.
You just missed the coldness, don't you?
Yeah, I know.
All right, what do we got? Function objects. Accumulate function accumulates data over the elements of the containing, for example, computing the sums. Initialize, accumulate from beginning to end, 0 with plus. All right. You can also use multiply. Wow. Do y'all see what it's doing? Could you write your own function?
You could always write your own function.
Right, you can write your own function to do it, to accumulate. Yep. Oh, all right. Squared sum. Wow. So if you wanted to use the user-defined squared sum, here's the example. Just pass it in and start at 0. Remember, that's your initial value. And squared sum will compute the sum of squares. Note the n1's the old value, n2 is the new one coming in. User-defined function objects. Right, we just did this. Yeah, notice the syntax int operator open close parentheses, because that's why you do squared underscored sum open close parentheses. That'll map to this function because the class is squared sum and the function is operator open close parentheses. Okay? That's how you do. So this is called a functor. Functor? Functor? Notice the class only contains one function, but the function is on the operator open close parentheses. So the way you pass that function of an object to a function is by putting the class name open close parentheses, and it'll pass that function. Okay, Sydney?
So the 0 is the N1.
Is the start. So you accumulate, start, you want to give it an initial value, 0. Because if you're multiplying, you probably want to start at 1.
Yes.
So you start at 0. On the first element, N1 would be 0, and N2 would be whatever the first element is. And then that's how it just keeps going down. The previous, your current accumulation, maybe your sum, is always N1, and N2 is the next variable coming in. All right, associative. We have not talked about these yet in this class, but just know that you can use sets and multi-sets, maps and multi-maps, which are going to behave very similarly to a hash table that you did in Java. Oh boy. Oh, this is just a set. Okay, good. No, but there's no E, so it is Patrick.
But I feel like if you're gonna name it Patrick and only have one of the letters at the end, you do a K.
Again, why do we constantly talk about our feelings?
Because our feelings are important. Because we're females. We are. That's why we bring it up, and then it becomes a discussion.
All right, tab new set fun.cpp. Oops, non-editor command. Oh yeah, you used to have it in. All right, we'll make it set. Let's see how many things actually convert over, because I know it's not everything. Let's test. I prefer doing that. Don't y'all? I'm glad we had that discussion. I knew it wouldn't be everything.
Wow.
Oh yeah, well, wasn't that bad. Has no member back. All right. So we can't do this print reverse business. Whoop. Let's see what else we don't have. We can't push back. That makes sense. What do we do instead? Is it insert? We insert. Because a set doesn't have a front and a back. Yeah, sorting makes no sense on a set. Wow. And what's next?
Everything.
All right, class set int has no member push back. Push back. Great. Who's using pushback? Oh, copy is probably using pushback. There we go. All right. Hey, look, when you add it to a set, it automatically sorted it. Okay, so we lose some capabilities, but what do we gain? Well, it doesn't tell you anything here, but notice that we're using set insert. You can also, when you create a set, actually list what the comparator is between the sets, so that the set will have a strict ordering to it. If a set has an ordering to it, what data structure do you think they use?
If the set doesn't have the order to it.
If it has an ordering to it, what data structure do you think they use?
Something that's ordered.
structure did we use that was ordered and efficient?
Binary trees?
Yes, a binary search tree. So yeah, sets in general use a binary search tree. Not all of them, but in general they do. So you can go through the iterators. I copy and pasted the code just to show you can do it again. Okay, well that was kind of weird. Why don't they, you know, that's weird because they don't go through the what's so nice about sets. Because you're used to math sets, right? What do you do with math sets?
What do you do with math sets? I'm familiar with them, but I don't remember. You sort? No. You do operations still?
Yes, you. Where is it? Begin, hold on, this isn't right. Find, count, lower bound, upper bound. Get a range of equal. Where are you?
Out there.
That would be bad if it's not here. Because the whole point of using a set is that you can do a union and an intersect.
Maybe you took it away.
I hope not. What's the union algorithm in C++? Set union, there we go. Okay. Constructs a sorted range between the located by results. All right, let's talk about this real quick because this is why it gets important. If you were to do a union between two arrays, and that's going to return the distinct elements that are in each one, what would be the runtime complexity of that? If you have an array and you're going to do a union between the two arrays, let's go do this on the board.
What is the union?
Yeah,
Would it just be N? Because you just said to go do the second vote. So you're at 2 N equals N. Oh no, you were erasing your glare.
Yeah, okay, fine.
Hey,
Actually, I can
see
still.
it.
Wait, where's glare? There
We
it
can
is. It's
see
right
it
here.
on the overhead.
All right, so we'll have set 1 equal to 1, 5, 93,
26.
262, 1, 2, 3, 4. One of the best numbers of all time. Set 2, 2, 5, 2, 6, 2, 999. Okay. So set 1, union, set 2. Oh, that was a weird set. Let's try to fix that real quick.
Let's try that again.
Set 1, union, set 2 equals
1, 2, 5, 93, 262, 99, 1, 2, 2,
1, 2, 5, 93, 262, 999, 1, 2, 3, 4. Okay.
Ta-da.
Ta-da! All right. What's the runtime complexity of this?
N.
N or 2n? Why is it actually 2n?
Because you have to get through both sets, both arrays.
If these sets were not ordered, let's go 1, 93, 1, 2, 3, 4, 5, 5, 2, 6, 2, and then we'll have 2, 6, 2, 5, 9, 9, 9, 2.
Why did it skip the 5 at first?
I'm just saying if they're unordered, what would be the runtime complexity? N squared. Why would it be n squared if they're not ordered? ton, right?
Yeah.
So, by forcing them to be ordered a certain way with a binary search tree, the union is just in, as opposed to down here where the union is going to be in squared because you have to constantly search. Because remember, your final set has to have only distinct elements. Okay? Similar case when it comes to intersection. All right? So that's the point. That's what set gives you, basically. It takes advantage of the ordering, aka you're using a binary search tree for efficiency. Okay. Multi-sets. So with a multi-set, you can just have more than one value. All right, let's go to maps real quick. Let's pause for